Session 3. Biomechanics and Manual Handling, Workshop, Assessment of Lifting Tasks Nov 27. Session Objectives. At the end of this presentation, you will be better able to discuss the important concepts of biomechanics and its relevance to safe lifting. Estimate the loads and forces involved in lifting tasks. Recommend interventions aimed at reducing forces that may adversely affect the worker. Biomechanics. Study of the mechanical loads on the human body. Force. Mechanical disturbance or load, e.g. push, pull, throw, kick, hold, sneeze, etc. Newton's laws of motion. Alt. Newton's first law, law of inertia. A body that is originally at rest will remain at rest. ASCII. Alt. A body moving with constant velocity in a straight line will maintain its motion until an external resultant force is applied. ASCII. Alt. Newton's second law, law of force and acceleration. Acceleration of a body is directionally proportional to the net force acting on the body and inversely proportional to its mass, A equals F/m. Force equals mass x acceleration. Alt. Newton's third law. For every action there is an equal and opposite reaction. Newton's third law, one reaction between two objects creates two forces, one on each exerted by the other. Newton's second law, multiple forces acting on the same object work together to determine how fast its motion changes. The change is in the direction of the total force. ASCII. Alt. Alt. Moment, torque. When a perpendicular force is applied on a lever arm at some distance from its axis of rotation, fulcrum, there is a rotational tendency that is termed torque or moment. A moment of a force, or a torque, is a measure of a force's tendency to cause a body to rotate. Moment, force, x, distance. Alt. Equilibrium or balance is achieved if the moments are equal and opposite. If force B is equal to force A and is applied on the other end of the fulcrum, equilibrium is achieved. Moment A equals moment B where force A times distance 1, equation A, equals force B times distance 2, equation B. Alt. Moment, Newton meter, equals force, Newton, x distance, meter. ASCII. Alt. ASCII. Alt. Moment, torque. Torques generated by the body translate muscle contractions into mechanical work and movements of the fingers, arms, legs, back. Alt. Alt. ASCII. Alt. ASCII. Alt. Example, moment at the L5S1 disc of the spine for the following scenarios, moment equals, weight of load, x, distance of load to pivots. ASCII. Alt. Work. Positive work, the product of muscle force and the force arm, Fx Fa, the product of the resistance and resistance arm, Rx Ra, movement occurs, dynamic torque. Illustration of horizontal distance of objects lifted from the body, figure 10. Predicted L5/S1 disc compression forces for varying loads in hands and postures, top, assuming either 5.7 cm back muscle moment arm with abdominal pressure effect, dashed lines, or 6.5 cm back muscle moment arm without abdominal pressure effect, solid lines, 7, compression forces for the varying loads and at different horizontal distances. ASCII. Alt. Decision points for safe lifting. Can the lifting task be done by one person? Is object too heavy to be lifted safely? Can the object be kept close to the body when lifting? Can lifting be done without bending the waist? Does the load have good handles or can be gripped easily? Methods to evaluate workplace factors for WMSD of the low back. Physical stress job analysis. 7 variables considered. Alt. Applications manual for the revised Naish lifting equation. The revised Naish lifting equation does not apply if any of the following occur. Lifting/lowering with one lifting/lowering for over 8 hours. Lifting/lowering while seated or kneeling. Lifting/lowering in a restricted workspace. Lifting/lowering unstable objects. Lifting/lowering while carrying, pushing, or pulling. Lifting/lowering with wheelbarrows or shovels. Lifting/lowering with high-speed motion, faster than about 30 inches/second. Lifting/lowering with unreasonable foot/floor coupling, 0.4 coefficient of friction between the sole and the floor. Lifting/lowering in an unfavorable environment, i.e., temperature significantly outside 66 to 79 degrees Fahrenheit, 19 to 26 degrees Celsius, range, relative humidity outside 35–50% range. Variables to consider when evaluating lifting task. 1. H equals horizontal location of the object relative to the body, distance of the object to the body. 2. V equals vertical location of the object relative to the floor, how high is the object to be lifted? 3. D equals distance where object is moved vertically. 4. A equals asymmetry angle or twisting while lifting. 5. F equals frequency and duration of lifting activity. 6. C equals coupling or quality of grip when lifting. 7. Weight of object being lifted, considered in computation of lifting index. ASCII. Alt. Recommended weight limit. RWL equals LCX HMX VMX DMX AMX FMX CM. Where RWL recommended weight limit. LC load constant. HM horizontal multiplier. VM vertical multiplier. DM distance multiplier. FM frequency multiplier. CM coupling multiplier. Package inspection. Inspects compact containers for damage on a low shelf. Lifts container with both hands directly in front of the body from shelf 1 to shelf 2. Rate of 3/min for 45 minutes. Significant control at destination. Can't step forward. Optimal design of container but no handle. ASCII. Alt. ASCII. Alt. ASCII. Alt. ASCII. Alt. ASCII. Alt. Lifting calculator. Developed by the Washington State Department of Labor and Industries. Simple lifting calculator based on NIOSH revised lifting equation. Can be used as screening tool to identify lifting tasks that need to be evaluated further using more comprehensive instruments. The lifting calculator involves 5 steps to analyze. Lifting task/S done under worst conditions, worst case scenario. Heaviest object lifted and the lift done in the most awkward posture. Analyze most commonly performed lift. Frequency and duration of lifting task considered in the calculation. DM equals vertical travel of hands to destination minus vertical travel of hands from origin, equals 59 minus 22 inches, equals 35 inches. ASCII. Alt. Asymmetric multiplier, 0 degrees equals 1 asymmetric multiplier. ASCII. Alt. Frequency multiplier, rate of 3 per minute for 45 minutes. ASCII. Alt. Coupling multiplier, decision tree for coupling quality. ASCII. Alt. Alt. Optimal design of container but no handle. ASCII. Alt. Final answer for RWL, 34.9 pounds for origin, 15.2 for destination. ASCII. Alt. Lifting index. Lifting index equals object weight over recommended weight limit. ASCII. Alt. Li greater than 1, needs improvement. Step 3. Compute the lifting index for origin and destination. ASCII. Alt. Calculator for analyzing lifting operations. ASCII. Alt. ASCII. Alt. ASCII. Alt. Interpretation. Estimation of level of physical stress. Lifting index equals actual weight/weight limit. ASCII. Alt. The greater the actual weight relative to the weight limit, the higher the lifting index. Goal, lifting index less than or equal to 1. ASCII. Alt. ASCII. Alt. ASCII. Alt. Practice, lifting calculator. Example 1, loading punch press stock, lift frequency, once per shift, duration is assumed to be less than 1 hour, grip when lifting, coupling fair because object is irregular but the fingers can flex 90 degrees, body is not twisted when lifting, ankle location assumes step forward with load. ASCII. Alt. Calculator for analyzing lifting operations, safe lifting calculator. ASCII. Alt. Frequency and duration. 15 times per minute for more than 4 hours per day. Weight of one bottle. 350 grams. Noisy and hot. ASCII. Alt. Evaluation of the impact of the revised National Institute for Occupational Safety and Health lifting equation. Systematic review of the literature on the RNLE. Evaluate impact of the revised National Institute for Occupational Safety and Health lifting equation, RNLE. Conclusions. Widely used job analysis tool for assessing or designing manual lifting tasks. Adoption of the RNLE as an ergonomic standard for use by various local, state, and international entities. Current scientific literature suggests a positive relationship between L/CLI metrics and the severity of LBP outcomes. Lifting Index, LI, is an estimate of risk. ASCII. Alt. Mobile app. ASCII. Alt. Key points. Biomechanical concepts allow estimation of loads to the body. Tools are available for risk assessment. Lifting task can be analyzed to determine level of risk in developing low back problem, niche lifting equation, lifting calculator. Several factors need to be considered when evaluating lifting task. Lifting task assessment tools can also be used to monitor improvements in the work process.